In this video, we're going to go over section 9.6 from our textbook. We're going to be evaluating trig functions. So an acute angle A is drawn in standard position, shown by this diagram here. Now we can easily see that when we draw an angle in standard position, this gives a right triangle. This angle here is going to be 90 degrees. Now along this x-axis here is our initial side, and here is our terminal side. Now the length of this side here of our triangle is going to be x, and it's also going to be called the adjacent side because it's adjacent to our angle A in standard position. On the other hand, this side of our right triangle y is going to be called the side opposite, or the opposite side, since it is exactly opposite from our angle. And then the length of this side of our right triangle is called the hypotenuse, and that's given by r here. Now the definition of trig functions for right triangles are given by these guys here. So sine of some angle A is going to be y over r. Going back to our diagram, we can see that that's the same as our opposite side over our hypotenuse. Similarly, for cosine of our angle A, that's going to be x over r. That's going to be the same thing as our adjacent side over our hypotenuse. Continuing with this logic here, we also have that tangent is going to be opposite over adjacent. Cosecant is going to be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent, and cotangent is going to be adjacent over our opposite side. So with that knowledge here, let's do this example. We want to find the exact values for our 6 trig functions of this angle A here. So our angle is given by this guy here. So the first thing we want to do is find sine of our angle A. Well, we know sine is going to be opposite over our hypotenuse. Opposite of this angle is going to be 15. And the hypotenuse of this right triangle is going to be given by this here, by 17. So that'll be our value for sine of our angle A. Similarly, cosine is going to be our adjacent over our hypotenuse. The adjacent side of this angle A here is given by 8. It's the side right next to it. And we know our hypotenuse is 17. Now for tangent, this is going to be the opposite over our adjacent side. Again, our opposite side is 15 and our adjacent side is 8. Now cosecant, secant, and cotangent are just going to be the reciprocal of those 3 that we just found, given by this here. Now a little trick that can help us to memorize all of this information here is this acronym SOHCAHTOA. This represents, for sine, we have opposite over hypotenuse. For cosine, we have adjacent over hypotenuse. For tangent, we have opposite over adjacent. Then with our knowledge of these reciprocal functions here, using this, we can figure out what these guys are. So this is very helpful. If you can't remember all of this, just remember SOHCAHTOA. All right, now let's move on to some special angles here. So these special angles that we'll see throughout this course are going to be 30 degrees, 45 degrees, and 60 degrees here. So these are some triangles here with these given angles. And the reason why these are special angles is because 30 degrees is exactly equal to pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. Okay? So we know exactly what these output values are for sine, cosine, tangent, and so on using the unit circle here. We can also use our knowledge of our Pythagorean theorem to easily find the side lengths of all of these sides with these degrees here. Now moving on to what's called cofunction identities. So if we're given a right triangle, ABC, so this means we have angle A, B, C here. C is going to be our right angle, and B and A are going to be acute angles, and these guys are actually called complementary angles. So sine of A here is going to be opposite over our hypotenuse, so A over C here, and that's going to be the same thing as cosine of our angle B, because cosine is going to be adjacent over hypotenuse. Similarly, for tangent of this angle A here, this is going to be A over B, which is going to be the same thing as cotangent of this angle B here. And lastly, secant of this angle A is going to be equal to cosecant of this angle B here. So these angles A and B are complementary. Now, since angles A and B are complementary, the functions sine and cosine are called cofunctions. And same thing for cosecant and secant and tangent and cotangent. Now, this brings us to our next definition, reference angles. So a reference angle for an angle theta is going to be written as theta prime here. That's what that means. And it's going to be the positive acute angle made by the terminal side of angle theta and the x-axis here. So we have different cases here. For example, if theta is acute, so it's in the first quadrant here, then theta is going to be equal to theta prime. Now, if theta is in the second quadrant here, then we're going to find this theta prime. It's going to be the angle between the negative x-axis here and this terminal side. And we can find that by taking 180 degrees and subtracting out this angle theta here, right? Because from here all the way to the negative x-axis, that's going to be 180 degrees. If we subtract out this angle here, we'll be left with this angle theta prime here. Similarly, if our angle theta is in the third quadrant here, what we'll do in that case is our reference angle is going to be the angle made with this terminal side and this negative axis here. So what we'll do is we'll take this angle theta and subtract out 180 degrees. So we're subtracting out everything here, and we'll be left with this angle here. Similarly, if our angle theta is in the fourth quadrant here, what we'll do is we'll subtract out 360 degrees and take away theta. So 360 degrees is one full rotation here. If we take away this angle theta here, we'll just be left with theta prime here. Okay, so we'll do exactly that for these examples here. We want to find the reference angle for the following. So for 302 degrees is going to be in the fourth quadrant here. So it is helpful to know at least your quadrantal angles. So that will be angles on the x and y axis, right? So on the y-axis, that'll be 90 degrees and 270. And on the x-axis, that'll be 180 and 0. So 302 degrees will be in the fourth quadrant. It'll be between 270 and 360 degrees. So in this case, our theta prime is going to be 360 degrees minus theta. And in this case, it's 302 degrees. So our reference angle is going to be 58 degrees. Now for part B here, we want to find the reference angle for negative 115 degrees. But before we can do that, notice that when we're finding our reference angle, theta is always going to be in standard position. So we're starting here at the x-axis and rotating in this direction, and our terminal side is given by these guys here. So in this case, this is not in standard position. This is negative 115 degrees, so we're actually starting on the x-axis and rotating in this direction. So before we can find the reference angle, what we're going to want to do is find its coterminal angle. And we saw that from section, I think, 9.1 or 9.2. So we can find this by adding a certain multiple of 360 degrees until we get an angle that is between 0 and 360 degrees. So adding 360 degrees to this, we'll get 245 degrees. And this angle is between 0 and 360, so we'll use this guy, and this angle is coterminal to 115 degrees. So our new theta that we're looking at is going to be 245 degrees. So this tells us our terminal side is going to be in the third quadrant here. This is 180 degrees and this is 270. So 245 will be in the third quadrant. So we'll use the formula. We're going to do theta minus 180. This will give us 65 degrees. So that'll be our reference angle for negative 115 degrees. Now doing the same thing here, we have negative 7 pi over 6. Again, first we want to find the coterminal angle for this guy because we have that it's negative. We'll keep this in terms of radians here. So if we're going to add 360 degrees to this guy, that's the same as adding 2 pi. So this would be negative 7 pi over 6 plus 12 pi over 6, which gives us 5 pi over 6. So an angle coterminal with minus 7 pi over 6 is 5 pi over 6. Now 5 pi over 6 is going to be in our second quadrant here. So we'll use this formula to find theta prime. And again, we want to do this in terms of radians. So instead of doing 180 minus 5 pi over 6, we'll do pi minus 5 pi over 6, since 180 degrees is equal to pi. Getting the same denominator here. We'll get pi over 6. So our reference angle to minus 7 pi over 6 is going to be pi over 6. Alright, so this brings us to this procedure for finding trig function values for any non-quadrantial angle. So any angle that's not on our x or y axes. So here is our procedure here. If theta is greater than 360 or less than 0 degrees, then we're going to find our coterminal angle. So we just saw how to do that in parts B and C here. Then we're going to find the reference angle. We also just did that. And then we're going to find the trig function values for that reference angle that we found. Okay. Then we want to determine the correct signs for the values found in that step. And this gives the values of the trig functions for the angle theta. So let's start with this example here. We want to find sine of 750 degrees. This angle is greater than 360 degrees, so we're going to have to find a coterminal angle. In this case, what we'll do is we'll subtract 360 degrees so that our angle is in between 0 and 360 degrees. Subtracting these guys, we'll get 390 degrees. Now, this angle still is not between 0 and 360 degrees, so that's fine. We'll just subtract out another rotation. Doing so, we'll get 30 degrees. Now what we want to do is find the reference angle theta. We have 30 degrees here, so this will be an acute angle. And if you remember, an acute angle is going to be in our first quadrant. And if this is the case, then our reference angle is just going to be the angle that we're dealing with. So our reference angle is just going to be 30 degrees. Now, what we want to do is find the trig function values for this reference angle. So sine of 750 degrees then is just going to be sine of our reference angle 30 degrees. Now using our unit circle, sine of 30 is just going to be 1/2. Now for step 4 here, we want to determine the correct signs for the values found in step 3. So we know that 750 degrees is going to lie in quadrant 1. Because its reference angle is going to be 30 degrees. Now because of this, our sine value is going to be positive. We know all of our y values in the first quadrant are going to be positive. All right. Now for part B here, again, we have that our angle is less than 0 degrees. So we're going to have to add a full rotation to that guy. So we're going to add 360 degrees to see if we get an angle between 0 and 360 degrees. Doing so, we'll get 120 degrees. So that'll be our coterminal angle for negative 240. Now, since 120 degrees, going back to our quadrants here, is going to lie in the second quadrant, we're going to use this formula to find our reference angle. So our reference angle, theta prime, is going to be 180 minus 120 degrees. So this gives us 60 degrees. Now, I'm skipping step 3 for a moment to find the trig function values for this reference angle because we want to determine the correct signs for the values. And we know that negative 240 degrees is going to lie in quadrant 2. This tells us that all of our x values are going to be negative. So cosine of the sky is negative. Now with that information, when we go to evaluate cosine of negative 240, we know that this is going to be minus cosine of our reference angle, which will be 60 degrees. So cosine of 60 is 1/2. So we'll get minus 1/2 here. Alright, and the last thing we'll look at is finding angle measures by hand. So this example here will illustrate how to do so. We want to find the acute angle theta that satisfies these given equations here. And first, what we want to do is express our answers as an inverse trig function and then as a measure of theta in degrees. So we're told that sine of theta is equal to 1/2, and we want to figure out what theta is. So what we can do is take the inverse of our sine functions on both sides of our equation. So we'll take sine inverse of sine theta. It's going to be equal to sine inverse of 1/2. Sine inverse and sine cancel each other out. So we're just left with theta is going to be equal to sine inverse of 1/2. So on your homework, when it asks you to first write this as an inverse trig function, this is what we're doing. We're using the fact that the inverse of sine is going to cancel with sine. Now, if we want to express our answer as a measure in degrees, here we'll use the unit circle. We know that sine of 30 degrees is going to give us exactly 1/2. So because of this, this tells us that theta must be equal to 30 degrees. Alright. We'll do the same thing for b here. First, we want to express this as an inverse trig function. So we'll take the inverse of tangent on both sides of our equation. So these guys will cancel, and we're left with theta is going to be equal to tangent inverse square root 3. Now we can use our calculators also to evaluate this and get a value for theta. But in this case, we're going to use the fact that tangent of theta is equal to sine of theta over cosine theta, and this must be equal to square root 3. Now again, using the values for our unit circle, we know that square root 3 must be equal to sine theta over cosine theta. Well, this will happen if sine theta is equal to root 3 over 2 and cosine theta is equal to 1/2. This is because this simplifies to square root 3 over 2 times 2 over 1, which gives us square root 3. So now what we want to do is then figure out when sine of theta will be equal to 3 over 2 and cosine of theta will be equal to 1/2. And again, looking at our unit circle, we can see that sine of 60 degrees gives us square root 3 over 2, and cosine of 60 degrees gives us 1/2. So it then must be the case that theta is equal to 60 degrees. Alright, so that'll be it for this video.